We will start in 1 minute. We'll continue reviewing for the final exam today. The final exam on Newton opens on Monday, May 4th at 3 p.m. and then it closes on Wednesday, May 6th at midnight or 11:59 p.m. There's a final exam practice on Newton. The last 10 minutes of today's class we'll stop, and then that will give you an opportunity to work on the course evaluations on Moodle. The deadline is at the end of the day today, so if you want to do the evaluations, you have to do it today. Okay, we picked up on where we left off on this problem, number 18. Solve the equation 2 times the square root of x equals x minus 3. We want to solve for x. Since the variable x is inside a square root, we have to square both sides. So that's how we start. We square the left-hand side and we square the right-hand side. So sometimes students forget what it means to square something. If you square something, you multiply it by itself. So I'll exhibit that. 2 times the square root of x times 2 times the square root of x on the left-hand side. On the right-hand side, x minus 3 times x minus 3. Okay, so 2 times the square root of x times 2 times the square root of x is 4 times the square root of x squared. On the right-hand side, x minus 3 times x minus 3, x squared minus 3x minus 3x a second time, and then negative 3 times negative 3 is positive 9. We're assuming that the variable x is positive, otherwise the square root of x wouldn't be a real number if it's not already positive. So the square root of x squared is x. The left-hand side is 4x. The right-hand side, when we combine like terms, is x squared minus 6x plus 9. And we'll make the left-hand side 0 by subtracting 4x from both sides. And we get 0 equals x squared minus 10x plus 9. We can solve this by factoring. If you don't see how to solve it by factoring, you can use the quadratic formula, or you could solve it by completing the square. The 2 factors are x minus 9 and x minus 1. And it's easy to verify that those are the correct factors. The quadratic equation has 2 solutions, x equals positive 9 and x equals positive 1. But in the original equation, 2 times the square root of x equals x minus 3, x equals 1 does not work. If you test x equals 1, you get 2 times the square root of 1 equals 1 minus 3, or 2 times 1 equals negative 2. That's false. So 1 is not a solution. On the other hand, x equals 9. 2 times the square root of 9 on the left-hand side. On the right-hand side, 9 minus 3. And the square root of 9 is 3, so 2 times 3 equals 6. that is obviously true. So x equals 9 is the only solution. Okay, in the next problem, use positive exponents only in the answer. Inside the parentheses, we have x to the 6th times y to the negative 4 in the numerator. And in the denominator, we have x squared times y squared. And that entire rational expression is raised to the exponent 1/2. So usually what I do is simplify inside the parentheses first, and then afterwards we'll apply the outer exponent 1/2. Okay, first focus on the variable x. In the numerator, x to the 6th, and in the denominator, x to the 2nd. That simplifies to x to the 4th in the numerator. So if you were to isolate that, x to the 6th divided by x to the 2nd, there's a number of ways that you can go about simplifying this. One way is just to use the property x to the 6th divided by x to the 2nd is x to the 6 minus 2, or x to the 4th. And the implication is that this is in the numerator. So that's why we're left with x to the 4th in this numerator. The other term, y to the negative 4 divided by y to the 2nd, that simplifies to y to the positive 6 in the denominator. So we can show why that has to be true. If we just isolate y to the negative 4 divided by y to the positive 2, once again, there's a number of ways we can go about simplifying this. If we use the same formula that we did over here, in the numerator, we get y to the negative 4 minus 2 over 1. But y to the negative 4 minus 2 is y to the negative 6. But then we have another property for negative exponents. Y to the negative 6 over 1 is equal to 1 over y to the positive 6. So that's why we have y to the positive 6 in the denominator. Then finally, apply the outer exponent 1/2. We're going to multiply this exponent 1/2 times each of those exponents. And in the numerator, x to the 1/2 times 4 is x to the 2nd. And in the denominator, y to the 1/2 times 6 is y to the 3rd. So our simplified result is x to the 2nd over y to the 3rd. Okay, the next problem, solve the equation with rational expressions. 6 divided by x plus 2 divided by x minus 5 equals 1. Okay, so the standard way is identify the least common denominator. The least common denominator is x times x minus 5. You can also multiply that out to get x squared minus 5x if you prefer. But now we multiply every term on both sides of this equation by the least common denominator. So in factored form, if I multiply x times x minus 5 over 1 by 6 over x, the x's cancel. X divided by x is 1. So we get 6 times x minus 5. And then we multiply x times x minus 5 times 2 over x minus 5. This time the x minus 5 factors cancel, so we get plus 2x. On the right-hand side, we multiply 1 times the least common denominator. This time we don't get any cancellations. So this time I'll multiply 1 times the expanded form of the least common denominator. So I get 1 times x squared minus 5x. Okay, this equation is quadratic, So we want to multiply everything out. We'll combine like terms, and then we'll solve for x. Okay, so on the left-hand side, 6x plus 2x is 8x. So we get 8x minus 30 equals x squared minus 5x. We'll make the left-hand side 0 by subtracting 8x and adding 30 to both sides. And we'll get 0 equals x to the second minus 13x plus 30. And this factors really nicely. The two factors are x minus 3 and x minus 10. So the two solutions to the quadratic equation are x equals positive 3 and x equals positive 10. The restricted values are x equals 0 and x equals 5, and neither of these numbers are restricted values. So it's a pretty good sign that these are both solutions. You can verify that each one is a solution by substitution. So I can tell by looking that x equals 3 is a solution. And verifying that 10 is a solution is also pretty easy. Yeah, it's turns out to be 3/5 plus 2/5, which is 5/5 equals 1. Yeah, so both of those check out. Hey, the next problem is to simplify a product of square roots. Simplify the square root of 3x to the third y to the fifth times the square root of 15xy. There's more than one way to do it. My preferred method, since we're multiplying two square roots, is to write it as a single square root and multiply the two radicands. 3 times 15 is 45. X to the third times x is x to the fourth. And y to the fifth times y is y to the sixth. And then we'll just focus on simplifying this square root. This can be simplified. The largest factor of 45 that's a perfect square is 9. 9 times 5 is 45. X to the fourth is a perfect square because the exponent 4 is a multiple of 2. Or another way to say something equivalent is that the exponent is an even integer. And y to the sixth is also a perfect square because the exponent 6 is even, a multiple of 2. Okay, so we'll rewrite this as the square root of 9x to the fourth y to the sixth multiplied by the square root of 5. So what I did was I grouped the perfect square factors in a single square root, and the remaining factor 5 is by itself. So the simplified answer, the square root of 9 is 3. The square root of x to the fourth is x to the second. The square root of y to the sixth is y to the third. And the final answer, 3 times x squared times y to the third times the square root of 5. Okay, number 22. Working together, Brad and Jim can paint the house interior in 6 hours. Working alone, Brad can do the painting in 15 hours. Find the amount of time it would take Jim to do the painting alone. Hey, this is a work problem. We've seen a bunch of these. Well, those of you who actually watch. So Brad and Jim, they work together, and in 6 hours they can paint the house. So Brad works at a rate. Jim works at a certain rate, and in 6 hours they can paint one house. Rate times time equals 1. Working alone, Brad can do the painting in 15 hours. Okay, so for Brad works at his rate, and in 15 hours he can paint one house. Find the amount of time it would take Jim to do the painting alone. So we'll pick a variable to represent the amount of time it takes Jim by himself. I'll just pick capital T to represent the number of hours it takes Jim by himself. Okay, then solve each equation for the rates. Brad's rate plus Jim's rate is 1/6. So more explicitly, it means that when Brad and Jim work together, they can paint 1/6 of the house per hour. That's their hourly rate. Brad's hourly rate is 1/15. Jim's hourly rate is represented by 1/T. Okay, so we replace Brad's rate with 1/15 in this equation. So 1/15 plus Jim's rate, which is plus 1/T. That's equal to 1/6. Okay, we want to solve for T. We see that T is in a denominator, so we'll clear denominators by multiplying every term on both sides by the least common multiple of the denominators. So the least common multiple of the denominators, I'll write that over here. Least common denominator is 30 times T. Okay, when you multiply 30T over 1 by 1/15, that simplifies to 2T. When you multiply 1/T times 30T, the T's cancel, so we just get plus 30. And on the right-hand side, 1/6 times 30T simplifies to 5T. So this is a really easy equation to solve for T. Subtract 2T from both sides. We get 30 equals 3T. Then divide both sides by 3. We get T equals 10. So that means Jim takes 10 hours by himself. So Jim takes 10 hours to paint the house by himself. Okay, the next problem, number 23. Simplify the square root of 75 minus the square root of 48 plus the square root of 50. Okay, the largest factor of 75 that's a perfect square is 25. 25 times 3 is 75. The largest factor of 48 that's a perfect square is 16. 16 times 3 is 48. The largest factor of 50 that's a perfect square is 25. So we rewrite this as the square root of 25 times the square root of 3 minus the square root of 16 times the square root of 3, and then plus the square root of 25 times the square root of 2. Then we get 5 times the square root of 3 minus 4 times the square root of 3 plus 5 times the square root of 2. Only 2 of the square roots are like radicals, so we can combine those two. 5 times the square root of 3 minus 4 times the square root of 3 is just the square root of 3, which we add to 5 times the square root of 2. This is as far as we can simplify that. Okay, the next problem, another equation with rational expressions. So this equation, we're told, has one solution. So find the solution. The denominators, 2 of the denominators are the same. So the least common denominator is just x times x plus 1. Sometimes students will write x times x plus 1 times x plus 1. That is not the least common denominator. And you can still make it work, but you make a whole lot more work in the process. So endeavor to use the least common denominator. Okay, we multiply each term on both sides by the least common denominator. When we multiply it by 3 over x plus 1, the x plus 1 factors cancel, and we're left with 3 times x. And then we multiply 4 over x times x plus 1. This time x cancels with x, and we're left with plus 4 times x plus 1. Then on the right-hand side, 6 over x plus 1 times the least common denominator. The x plus 1 factors cancel, and we have 6x left. Okay, this is a very simple equation to solve, so we just do a little bit of algebra and arithmetic. So on the left-hand side, we get 7x plus 4. On the right-hand side, 6x. So we can do this in a couple of ways. One way is to subtract 6x from both sides. 7x minus 6x is x, so I get x plus 4 equals 0, and then subtract 4 from both sides. We get x equals negative 4 for the only solution. Just note that the restricted values are negative 1 and 0. And the next problem, multiply and simplify. So we're multiplying the quantity 2 times the square root of 5 minus 3 times the square root of 7 by another quantity, the square root of 5 plus the square root of 7. So multiply these two expressions the same way that you would multiply two binomials. They are similar to binomials in that sense. So 2 times the square root of 5 times the square root of 5 is 2 times the square root of 25. And then plus 2 times the square root of 5 times the square root of 7 is plus 2 times the square root of 35. And then we're subtracting 3 times the square root of 7 times the square root of 5. So this should be the square root of 35. Okay, so minus 3 times the square root of 35. And then finally, we're subtracting 3 times the square root of 7 times the square root of 7, which is minus 3 times the square root of 49. Okay, 2 times the square root of 25 simplifies in the first step to 2 times 5. The next two radicals are like radicals, so we can combine them by adding and subtracting. So plus 2 times the square root of 35 minus 3 times the square root of 35 simplifies to minus the square root of 35. This is like minus 1 times the square root of 35. And then minus 3 times 7, since 7 is the square root of 49. 2 times 5 is 10. 10 minus the square root of 35 minus 21. And finally, 10 minus 21 is negative 11. So our simplified answer is negative 11 minus the square root of 35. Okay, the next problem, another word problem. George walked 24 miles in the same time Thomas walked 16 miles. Thomas's rate was 2 miles per hour slower than George's rate. Find their walking rates. Okay, it makes sense. Thomas's rate has to be slower than George's rate because in the same amount of time, George walked a further distance than Thomas. Okay, so this problem involves equations that have the form rate times time equals distance. So that's pretty apparent because a distance of 24 miles and a distance of 16 miles are mentioned, and Thomas's rate and George's rate are mentioned. Time is mentioned. So rate times time equals distance. So we'll write one of those, rate times time equals distance, for George and for Thomas. We want to find their rates. So we have a couple of options. We can say, this is just one way to do it, Thomas's rate. We can represent that by x miles per hour. And then George's rate, well, Thomas's rate is 2 miles per hour slower than George's rate, or equivalently, George's rate is 2 miles per hour faster than Thomas's rate. So we can represent George's rate by x plus 2 miles per hour, because it's 2 miles per hour faster than Thomas's rate. Okay, for George, we can write a rate times time equals distance equation. His rate is x plus 2 miles per hour. And he can walk 24 miles in the same amount of time that Thomas can walk 16 miles. Okay, so Thomas's rate, we're using x to represent Thomas's rate. And he walks just 16 miles in the same amount of time that George walks 24 miles. Okay, we want to solve for x because we're trying to find Thomas's rate and George's rate. So just note, the times are the same. That means George's time t is the same as Thomas's time t. So what we can do is solve each of the two equations for time. Time for George is his distance divided by his rate. Time for Thomas is his distance divided by his rate. But the two times are the same, so our equation is 24 over x plus 2 equals 16 over x. Okay, so this is a pretty simple equation to solve. We can do it in one of two ways. We can multiply both sides by the least common denominator, which is just x times x plus 2. Or we can remember, whenever one rational expression equals another rational expression, then cross products are equal. Either way, we get the same equation, whether we multiply both sides by the least common denominator or just use cross products are equal. Okay, so 24x equals 16x plus 32. Subtract 16x from both sides, we get 8x equals 32. And then divide both sides by 8, x equals 4. So Thomas's rate is 4 miles per hour. So 4 miles per hour for Thomas. George's rate is 2 miles per hour faster, so his rate is 6 miles per hour. Okay, and number 27, find all restricted values of the rational expression. So 9x divided by x squared minus 6x plus 8. Okay, so we're just focusing on the denominator. The x values that make the denominator 0 are the restricted values. So if we just set the denominator equal to 0 and then solve the quadratic equation, the solutions are the restricted values, which means that we are not permitted to use them in that expression. Well, we can solve this by factoring easily enough. If you can't see how to solve it by factoring, you can always use the quadratic formula. But one factor is x minus 2, the other one is x minus 4. The solutions to this equation are positive 2 and positive 4. So the restricted values, are 2 and 4 for x. Okay, the next problem, number 28. So make sure you read the directions carefully when taking the final. Sometimes some of the work will be done for you. Like in this case, we're shown this equation with rational expressions. And then it says after clearing denominators, this equation becomes this quadratic equation. Well, it turns out that it's not exactly quadratic, but anyway, just solve this equation instead of taking the time to start from ground zero. Just solve this equation. Do note, though, that the restricted values are negative 4 and 0. If it turns out that the solution to this equation is a restricted value, then you have to say no solution. Okay, so we just multiply everything out. X times 3x plus 7 is 3x squared plus 7x. And then be careful here, we have to subtract 5x, but we also have to subtract 5 times 4, meaning we're subtracting 20. Then on the right-hand side, 3x times x plus 4 is 3x squared plus 12x. Both sides have 3x squared, so when we subtract 3x squared from both sides, all of the x squared terms are eliminated. Then on the left-hand side, 7x minus 5x is 2x. So we get 2x minus 20 equals 12x. Then we can subtract 2x from both sides, so that negative 20 equals 10x. And then divide both sides by 10. And we get x equals negative 2 for the solution. So negative 2 is not a restricted value, so we'll say that that's the solution. If you want to check to make sure it works, then replace every x with negative 2. Okay, number 29, a system of two linear equations. Solve the system. The two practical algebraic methods are to solve by substitution, or the other one is elimination. So you could use either method. So how about if I use substitution? I'll solve the top equation for y. So I have other options, but if I just pick the top equation and solve the top equation for y, then I start with, by subtracting 4x, I get 2y equals negative 4x plus 2. And then divide every term on both sides by 2, I get y equals negative 2x plus 1. And then in the other equation, I'm going to replace y with negative 2x plus 1. That's the substitution step. So I get 5x minus 3 times the quantity negative 2x plus 1 equals 19. And then we solve this equation for x. So we always have to be careful with the arithmetic. So we get 5x minus 3 times negative 2x. So that is equivalent to adding 6x. And then negative 3 times positive 1 is negative 3. So that is written as minus 3 equals 19. Combine like terms, 5x plus 6x is 11x minus 3 equals 19. Add 3 to both sides, 11x equals 22. And then divide both sides by 11, x equals positive 2. Hey, we still need to find y, but we can use this equation and substitution, replace x with 2, so we get y equals negative 2 times 2 plus 1, or y equals negative 4 plus 1, which means y equals negative 3. Okay, so the solution to the system of two linear equations is the ordered pair 2, negative 3. So this means x is 2 and y is negative 3. Okay, the next problem, completely factor the polynomial 16x to the second plus 24xy plus 9y to the second. You can use the AC method, or you can recognize this as a perfect square trinomial. The term on the left is a perfect square. So you can recognize this as a perfect square trinomial this way. The term 16x to the second is equivalent to squaring the term 4x. The term on the right is 9y to the second. That's equivalent to squaring the term 3y. And the middle term plus 24xy, that's equivalent to adding 2 times 4x times 3y. You can verify 2 times 4x is 8x. 8x times 3y is 24xy. So this has the pattern or the required characteristics of a perfect square trinomial. So that means its two binomial factors are identical. Both binomials are 4x plus 3y. So 4x plus 3y times 4x plus 3y are the two factors. And you can, even if you don't do all of this work, if you suspect that it's a perfect square trinomial and write down these two factors, you can verify by multiplying those two factors that they are the correct factors. Okay, the next problem that we'll look at, number 31, solve the equation x squared minus 6x equals negative 9. Well, there's no excuse for not knowing how to solve a quadratic equation. But we can solve this one by factoring. If we add 9 to both sides, then x squared minus 6x plus 9, that's another perfect square trinomial. Its two factors are identical, x minus 3 times x minus 3. So there's just one solution, but we say that it's a repeated solution. So x equals 3 is the repeated solution. Okay, so number 32, simplify. Use positive exponents only in the answer. Okay, so if we simplify what's on the inside of the parentheses first, then afterwards we can apply the outer exponent 2. Well, when we look at the coefficients, 3 is the coefficient in the numerator, 1 is the coefficient in the denominator. 3 divided by 1 is still 3, so we still have 3 in the numerator. Then x to the negative 1 in the numerator divided by x to the positive 3 in the denominator, that simplifies to x to the positive 4 in the denominator. And then for the variable y, we have y to the second in the numerator divided by y to the negative 2 in the denominator. That simplifies to y to the fourth in the numerator. And then think of 3 as 3 to the first, because we're going to apply the outer exponent by multiplying this outer exponent 2 times each of those exponents. And we get 3 to the 2 times 1, or 3 to the second, times y to the 8th, because 2 times 4 is 8, divided by x to the 8th, because 2 times 4 is 8. And then one step more, 3 to the second simplifies to 9. So our final answer is 9y to the 8th over x to the 8th. Okay, it is 10 minutes till, so I'm supposed to use the last 10 minutes today to give you an opportunity to log into Moodle and do the course evaluations. So if you don't do it now, and if you want to do it and you haven't done it, then you have until the end of the day today to complete that. We'll start in 1 minute. We'll continue reviewing for the final exam today. Remember that you have to take the final exam on Newton. It opens on May 4th at 3 p.m. and closes on Wednesday, May 6th at midnight or 1 minute before midnight. So the final exam, after you open it, it will remain open for 2 hours and 10 minutes. So you should take the final exam practice on Newton just so that you can work out any glitches that might occur. The last 10 minutes today, I'll give you an opportunity to log into Moodle and do the course evaluations. So for now, let's continue the review for the final exam. We got to this problem last time. A rock is catapulted. Its height above the ground t seconds after launch is h equals negative 16 t to the second plus 60 t feet. Find the number of seconds it takes for the rock to be 32 feet above the ground. Okay, so what we do, we replace h with 32 because h represents the height of the rock above the ground, and then we solve the resulting equation. So replace h with 32, we get 32 equals negative 16 t to the second plus 60 t. This is just a quadratic equation in the variable t. So we'll make the right-hand side 0 by adding 16 t to the second and subtracting 60 t. So we'll get 16 t to the second minus 60 t plus 32 equals 0. And now all we have to do is solve this quadratic equation. We can use the numbers as they are, but note that the greatest common factor of all three terms is 4. So if we divide every term on both sides of this equation by 4, we'll make the arithmetic a little bit easier. When we divide every term on both sides by 4, we get 4t to the second minus 15t plus 8 equals 0. And then we'll use the quadratic formula with a is a equal to 4, c equals negative 15. I said that wrong. A is 4, b is negative 15, and c is 8. So we get t equals the negative of negative 15 plus and minus the square root of the number negative 15 squared minus 4 times 4 times 8. All divided by 2 times 4. So we get t equals positive 15 plus and minus the square root of a number all divided by 8. 2 times 4 is 8. So inside the square root, the number negative 15 squared is 225. And we're subtracting 4 times 4 times 8. 16 times 8 is 128, so we're subtracting 128 from 225. So there are two positive solutions. So So 1 is 15 minus the square root of 97, all divided by 8. The square root of 97 is a little bit less than 10, and 15 minus 10 is positive. So the smallest solution is positive. The other solution, t equals 15 plus the square root of 97. Both of these solutions apply to this problem. After the rock is catapulted, it first reaches 32 feet after this many seconds while it's being launched upward. So this is about, well, 15 minus 10 is 5, so 5/8, approximately 5/8 of a second after the rock is catapulted, its height reaches 32 feet. But then, as expected, the rock reaches its maximum height and then starts to fall back down to the ground. And on the way down, it is at a height of 32 feet a second time. So this number is a little bit more than 3 seconds. So both of those are answers to this. Okay, the next problem, solve the quadratic equation 3x squared minus 7x minus 2 equals 0. So we'll use the quadratic formula. A equals 3, B equals -7, and C equals -2. So x equals the negative of -7 plus and minus the square root of the number -7 squared minus 4 times 3 times -2. And this is all divided by 2 times 3. Then we do the arithmetic. The negative of -7 is +7 plus and minus square root of the number -7 squared is 49. And we're subtracting 4 times 3 times -2. So 4 times 3 times -2 is -24. So we're subtracting -24, which is equivalent to adding 24. And then we're dividing it all by 6. So there's just one more step. X equals 7 plus and minus the square root of 73, all divided by 6. The square root of 73 cannot be simplified any further, so these are the two solutions. Okay, number 8. Write the standard equation of the circle, x squared minus 7x plus y squared plus 9y equals 1/2. And then after writing the standard equation, find the center and the radius. So we have to complete the square twice to get it into standard form. So we'll write x squared minus 7x. Leave some space before you write plus y squared plus 9y. Then leave more space between 9y and the equal sign, and then write 1/2. Okay, we will add a number to x squared minus 7x to create a perfect square trinomial, and we have to add the same number to the other side. And also we'll add a number to y squared plus 9y to both sides. Okay, so what number to add to x squared minus 7x? And then we'll find the number to add to y squared plus 9y. Okay, up here I'll do some of that work. Now that the coefficient of, or since the coefficient of x squared is 1, to complete the square, we take 1/2 of -7, which is -7/2. And then we square the number -7/2. And when you square the number -7/2, you get positive 49/4. So we're going to add 49/4 to both sides of this equation. And now we complete the square on y squared plus 9y. So to complete the square here, we take 1/2 of 9. 1/2 times 9 is 9/2. And we square 9/2 to get 81/4. So we have to add 81/4 to both sides. Okay, on the right-hand side, we have to add these three fractions. The least common denominator is 4, and 1/2 is equivalent to 2/4. So we can add these up. So 2/4 plus 49/4 plus 81/4 is 132/4. Okay, then the next step, we'll write the standard equation. X squared minus 7x plus 49/4 is x minus 7/2 squared. And the other trinomial, y squared plus 9y plus 81/4, that's equivalent to y plus 9/2 squared. And then the right-hand side is the radius squared. So the right-hand side is 132/4. Okay, the center, the x-coordinate of the center is positive 7/2. And the y-coordinate of the center is negative 9/2. And the radius is the positive square root of 132/4. So you can simplify that. I'll leave that for you to do. Simplify the square root of 132/4 for the radius. Okay, let's move on to number 9. Solve the quadratic inequality. X squared minus 2x minus 15 is greater than 0. So one side is 0. If we can factor the left-hand side, then we'll know what the endpoints are. And this factors really nicely. One factor is x plus 3. The other factor is x minus 5. And the inequality is greater than 0. So the endpoints are negative 3 and positive 5. Those are the endpoints. So just like we've been doing, we plot the endpoints, negative 3 and 5, and then we pick a test point from each of the 3 intervals. Okay, in the interval on the left, I'll pick x to be negative 4, and I'm going to use the factored form. Negative 4 plus 3 is negative 1. Negative 4 minus 5 is negative 9. The inequality is greater than 0. So the left-hand side is positive, and negative 1 times negative 9 is positive 9. So this is true. So the numbers from negative infinity to negative 3 are solutions. In the middle interval, pick x to be 0. This time I'll use the original inequality because replacing x with 0 is simple, and we're left with negative 15 is greater than 0, but this one is false. And then in the third interval, we can pick x to be 6. In the factored form, replace every x with 6. 6 plus 3 is 9. 6 minus 5 is 1. 9 times 1 greater than 0 is true. So yes, all of the numbers from 5 to infinity. The numbers negative 3 to 5, those are not solutions. We exclude the endpoints because the inequality does not have the or equal to part, so we exclude the endpoints. Graphically, we put a parenthesis at those endpoints. Okay, the interval notation, for this part of the number line, that's negative infinity, comma, negative 3, parenthesis. And then the union symbol the other part of the number line is parenthesis 5 comma infinity. Okay, let's do the next inequality. This one is a rational inequality. We can tell what the endpoints are. The x value that makes the numerator 0 is -1. So -1 is an endpoint. The x value that makes the denominator 0 is +3. So that's the other endpoint. And then remember that for rational expressions, endpoints that come from denominators are not part of the solution because division by 0 is undefined. The other endpoint, the one that comes from the numerator, it may or may not be part of the solution set. It depends on the inequality. Since this inequality is less than or equal to 0, the endpoint that comes from the numerator will be included. Okay, but we plot the numbers -1 and 3. We have 3 intervals to test. So in the first interval on the left, pick x to be -2. So in the numerator, -2 plus 1 is -1. In the denominator, -2 minus 3 is -5. This is a positive number. -1 divided by -5 is 1/5. The inequality less than or equal to 0, though, is false. So that is false. So none of the numbers from -infinity to -1 are solutions. In the middle interval, I'll pick x to be 0 for the test point. In the inequality, replace every x with 0. 0 plus 1 in the numerator is 1. 0 minus 3 in the denominator is -3. This is a negative number, and a negative number less than or equal to 0 that's true. So the numbers between -1 and 3 are solutions. Then in the third interval, pick x equals 4 or any other number greater than 3. So in the numerator, 4 plus 1 is 5. In the denominator, 4 minus 3 is 1. And this positive number less than or equal to 0, that's false. So none of the numbers greater than 3 are solutions. Okay, and we already noted that -1 will be included in the solution and +3 will be excluded, and just the other numbers between -1 and 3. The interval notation then is bracket -1 comma 3 parenthesis for the solution set. The algebraic notation, -1 less than or equal to x, which is less than 3. That's the algebraic notation. Okay, next problem to review, we have an application problem. Okay, this one says Bob and Cindy can trim the hedges in 3 hours when working together. Working alone, Bob takes 1 hour longer than Cindy. Find the amount of time it takes each to trim the hedges alone. This is a work problem. They work together or they work separately to complete one job doing something. In this case, they're trimming hedges. So when they work together, they can complete the job in 3 hours. So Bob works at a certain rate. We add that to Cindy's rate, and in 3 hours, they trim the hedges. Working alone, Bob takes 1 hour longer than Cindy. So we can pick T to be the time for Cindy. We don't know how much time she takes yet, so we write Cindy's rate times T hours equals 1. Rate times time equals 1. And then for Bob, we're told that Bob takes 1 hour longer than Cindy, so Bob takes t plus 1 hours. So maybe I should have labeled this t hours for Cindy and t plus 1 hours for Bob. Those are the times. Okay, so Bob's rate times t plus 1 hours equals 1. Okay, so we solve each of those equations for the rate. Bob's rate plus Cindy's rate is 1/3. Cindy's rate is 1 over t. Bob's rate is 1 over t plus 1. Okay, since I'm going to run out of space, I'll just write the next step on another piece of paper. Replace Bob's rate with 1 over t plus 1. So we get 1 over t plus 1. We're adding that to Cindy's rate, which is 1 over t. And the sum of the rates is 1/3. So we've seen how to do this kind of thing a few times. The least common denominator is 3 times t times the binomial t plus 1. Then multiply every term on both sides of that equation by 3 times t plus 1. So in the first one, when we multiply 1 over t plus 1 times the least common denominator, the t plus 1 factors cancel. So, and we're just left with 3 times t. Then multiply 3t times t plus 1 by 1 over t. The t's cancel. This time we have 3 times t plus 1. And then on the right-hand side, 1 over 3 times t plus 1. The 3's cancel. So we're left with t times t plus 1. This equation is quadratic in the variable capital T. So we multiply everything out. We'll combine like terms. We'll set one side equal to 0. And then solve for t. So we'll subtract 6t from both sides and subtract 3 from both sides. And we get 0 equals t to the second minus 5t minus 3. Well, unfortunately, t squared minus 5t minus 3 cannot be factored with integer coefficients. So we'll use the quadratic formula with a equals 1, b equals -5, and c equals -3. Okay, so we get t equals the negative of -5 plus and minus the square root of the number -5 squared minus 4 times 1 times -3, all divided by 2 times 1. And then the negative of -5 is 5 plus and minus the square root of the number -5 squared is 25. And we're subtracting 4 times 1 times -3. We're subtracting -12, which is equivalent to adding 12. And then we're dividing it all by 2. Notice that the square root of 25 plus 12 is the square root of 37, which is a little bit bigger than 6 because the square root of 36 is 6. So the solution that we get by subtracting is negative, but in this problem, negative solutions for time don't make sense. So we'll just use the solution we get by adding 5 plus the square root of 37 divided by 2. Okay, so Cindy's time, as noted, the square root of 37 is a little bit bigger than 6. So 5 plus that number, a little bit bigger than 6 divided by 2, is a little bit bigger than 5.5 hours. And so Cindy takes about 5.5 hours. Bob takes 1 hour longer, so his time is about 6.5 hours. If you have to use a calculator to round, to the nearest tenth, then you've done that before. Okay, we'll move on to the next problem. Okay, number 12. This one says simplify 27 over 8 raised to the 2/3 power. Okay, the exponent is a fraction. The denominator of the exponent is 3, so that implies a cubed root. And notice that both 27 and 8 are perfect cubes. So this is going to work out really nicely. We can rewrite this as 27/8 to the 1/3 all raised to the exponent 2. So I just used a property of exponents. So if you multiply the exponent 2 times the exponent 1/3, you just get the exponent 2/3. Okay, but writing it this way, we can see a little bit more clearly, perhaps, that we're going to be taking cubed roots of perfect cubes. So the fraction 27 over 8 to the 1/3 is equivalent to 27 to the 1/3 divided by 8 to the 1/3. But 27 to the 1/3 simplifies to 3, because the cubed root of 27 is 3, and 8 to the 1/3 simplifies to 2. And so we're left with 3/2 to the second, which is 3/2 times 3/2, or 9/4, is the simplified answer. Okay, the next problem, number 13. Change the term 3x raised to the 2/5 to an equivalent expression in radical notation. Okay, the exponent is the fraction 2/5. We want to convert this to radical notation. So since the denominator of the exponent is 5, the index of the radical is also 5. You can rewrite this as 3x to the second to the 1/5. I'm writing it this way because I want to convert to a radical with index 5. So if you raise something to the 1/5 and you want to write it in radical notation, then you write the radical with the index 5, and then put whatever else is inside the radical. This time it's the term 3x squared. If you write 3x squared without parentheses, that's incorrect. So this is an acceptable way to write it. But if you don't want the parentheses, then you have to square the term 3x. So when you square the term 3x, you get 9x to the second. So either of these two is acceptable. Just one thing that you have to watch out for: if you remove the parentheses and write 3x squared, that's incorrect. Okay, the next problem, simplify the cubed root of 125x to the 15th over 27y to the 12th. Okay, this works out pretty nicely. 125 is a perfect cube because 5 to the 3rd is 125. X to the 15th is a perfect cube because the exponent 15 is a multiple of 3. 3 times 5 is 15. And also in the denominator inside the radical with index 3, 27 is a perfect cube, and so is y to the 12th, because y to the 12th is a multiple of 3. You can simplify it all at once if you want, or you can do it in a couple of steps. You can rewrite the numerator as the cubed root of 125x to the 15th divided by the denominator, which is the cubed root of 27y to the 12th. And as we already noted, the cubed root of 125 is 5. The cubed root of x to the 15th is x to the 5th because the exponent 15 divided by 3 is 5. And we're dividing that by the cubed root of 27, which is 3. And the cubed root of y to the 12th is y to the 4th because the exponent 12 divided by the index 3 equals 4. Okay, the next problem, rationalize the denominator and simplify if necessary. Okay, we know that this is not simplified because we have a rational expression inside a square root. So that is not simplified. We can write the square root of 64 over x to the third as the square root of 64 over the square root of x to the third to start with. And we can see that the square root of 64 in the numerator simplifies to 8, so we might as well simplify that. And we still have the square root of x to the third in the denominator. So the denominator is irrational because it has the square root there. So to rationalize the denominator means that we want to find something that is equivalent to this, but with no square root in the denominator. Now, there's more than one way to go about doing this, but what I suggest is, since the denominator is the square root of x to the third, identify what you would have to, identify the least or the minimal thing that you would have to multiply by x to the third to get a perfect square. Remember, the process involves multiplying by 1 in a special form. And the idea is if we multiply something by 1, we're not changing its value. Okay, so as the question that was asked a few seconds ago, what would I have to multiply by x to the third to get a perfect square? Well, the least thing would be to multiply x to the third times x. X to the third times x is x to the fourth, and x to the fourth is a perfect square. So if I multiply by 1 in the form the square root of x divided by the square root of x, then I'll be able to rationalize the denominator. So in the numerator, we have 8 times the square root of x. In the denominator, the square root of x to the third times the square root of x is the square root of x to the fourth. And then the final step, 8 times the square root of x in the numerator. Remember that square roots have indexes of 2, even though we don't normally write it. But the square root of x to the fourth is x to the second because the exponent 4 divided by the index 2 is 2. Okay, so now we have a simplified expression. Okay, in the next problem, we'll simplify a cubed root. Simplify the cubed root of 54y to the 14th. The largest factor of 54 that's a perfect cube is 27. 27 times 2 is 54. And the largest factor of y to the 14th that is a perfect cube is y to the 12th. So we'll rewrite this so that the perfect cube factors are farther to the left. The cube root of 27 y to the 12th times the cubed root of the remaining factors, which are 2y to the second. Then the cubed root of 27 is 3. The cubed root of y to the 12th is y to the 4th. And so our final answer is 3y to the 4th times the cubed root of 2y to the second. Okay, if you're answering a problem like this on the Knewton final, if you omit the index 3, then of course Knewton will count it wrong because it's interpreting what that would be as a square root instead of a cubed root. So it will be important for you to write work down on paper. So if you write something correct on paper, but then write the incorrect answer in Newton, then you can get partial credit for that afterwards. Okay, they simplify the square roots of negative numbers. The square root of negative 81. Well, think of this as the square root of 81 times the square root of negative 1. The square root of 81 is just 9, and then we replace the square root of negative 1 with I. So 9i is the simplified answer. For the square root of negative 98, think of the square root of negative 98 as the square root of positive 98 times the square root of negative 1. The square root of 98 can be simplified. The largest factor of 98 that's a perfect square is 49. So in the next step, we'll write the square root of 49 times the square root of 2, but we'll go ahead and replace the square root of negative 1 with I. And then the last step, the square root of 49 is 7. So 7 times the square root of 2 times I is the simplified answer. Okay, on number 18, solve the equation 2 times the square root of x equals x minus 3. We want to solve for x. We see that x appears as the radicand of a square root. So that implies that we will need to square both sides of the equation to get x out of the square root. So we'll square the left-hand side, 2 times the square root of x squared. And we also square the right-hand side. And then sometimes students forget what it means to square something, so I'll sort of reiterate that. When you square the term 2 times the square root of x, it means to multiply this 2 times the square root of x times 2 times the square root of x. On the right-hand side, x minus 3 squared means x minus 3 times x minus 3. And then 2 times the square root of x times 2 times the square root of x is 4 times the square root of x squared. On the right-hand side, x minus 3 times x minus 3 is x squared minus 3x a second time, and then negative 3 times negative 3 is positive 9, so we write plus 9. Okay, the square root of x squared simplifies to x, so the left-hand side is 4x, and then we combine the like terms on the right-hand side, and we get x squared minus 6x plus 9. And then we subtract 4x from both sides. We get 0 equals x squared minus 10x plus 9. This equation, this is a quadratic equation that can be solved easily by factoring. If you don't see how to solve it by factoring, you can always use the quadratic formula. So the two factors are x minus 1. I was right, but I wrote x minus 9. X minus 9 times x minus 1. The quadratic equation has 2 solutions. One is positive 9, and the other one is positive 1. Okay, but note, if we check these answers, x equals negative 1, we get a problem. Replace every x with 1. We get 2 times the square root of 1 on the left-hand side. On the right-hand side, we get 1 minus 3. And the square root of 1 is 1, so 2 times 1 equals negative 2. That's false. So that's false. So that means 1 is not a solution to that original equation. Then check x equals 9. We get 2 times the square root of 9 equals 9 minus 3. The principal square root of 9 is 3. So 2 times 3 equals 6. This one's true. So x equals 9 is the only solution. In general, when solving equations that involve the square root of the variable that you're solving for, by squaring both sides, you can introduce extraneous solutions, and that's what happened in this case. So that's why you should always check to make sure that the solutions work in the original equation. Okay, it's almost 10 minutes till I am supposed to give you an opportunity to log into Moodle during class time to do the student evaluations. And so I'll do that now. So the last 10 minutes plus a few seconds are for logging into Moodle and doing the course evaluations. So you can do that now.